Let's start with this tiny but powerful board, the ESP32-C3 Super Mini. It may be small in size, but it has some amazing features. You get Wi Fi, Bluetooth 5, and a fast RISC-V processor, better security, and it's easier to use in modern projects. You can think of it like an upgraded version of the ESP8266, but much better. It has more features, RISC-V, a modern open source processor. It has Wi Fi and Bluetooth, so you can build wireless projects easily. It uses very little power, perfect for battery based gadgets. It has USB built in, no need for extra cables or converters, and it's super compact, great for small spaces or portable projects. If you've used ESP8266, this is a much better version, faster, safer, and more flexible. If you've used ESP32, this one is simpler. It has only one core instead of two, but it's smaller and uses less power. If you're building smart devices, sensors, wireless controls, or small IoT projects, the ESP32C3 Super Mini is perfect. It's budget friendly, easy to get started with, and powerful enough for real world use. Alright, now let's take a quick tour of the ESP32C3 Super Mini. This is what it looks like. Super tiny, but packed with everything you need to build wireless projects. USB-C port, this is where you connect your board to your computer. It's used for both power and uploading code. No extra USB to serial adapter needed. Just plug and play. Onboard LED, there's usually a small LED on the board connected to a pin like GPIO 8 or GPIO 2. We'll use this in our first program to blink and test. Power supply. The board runs on 3.3 volts logic. So if you're connecting external sensors or modules, make sure they also work at 3.3 volts, not 5 volts. You'll notice a row of small pins on both sides. These are called GPIOs, General Purpose Input Output. You can use these pins to connect sensors, LEDs, buttons relays, and many other components. Some pins also support PWM, ADC, I2C, and SPI, perfect for advanced projects. I'll cover that in more detail later. And that's your quick hardware overview. It's small, simple, and ready to go. All right, now open up the Arduino IDE, go to File, and then Preferences. In the Additional Board Manager URLs field, paste this link. You probably already have it. And then just click OK. Now go to Boards Manager, just click here. In the search box, type ESP32. You'll see a package by Espressive Systems. Click Install. This will install support for all ESP32 boards, including our ESP32C3. After installation, go to Tools, then Board, and select ESP32C3 Dev Board if it's available. If it doesn't show up, just restart the IDE. And then now go to Tools, Port, and choose the COM port that shows your board. If you're not sure which one it is, just unplug your board and plug it back in. The new COM port that appears is your board. Pretty easy. Now, most ESP32C3 boards, like the Super Mini, already have USB drivers built in. So usually you don't need to install like a CH340 or CP2102 drivers or anything like that. All right, now it's time to bring this board to life. Let's upload our very first sketch, the classic Blink program. In the Arduino IDE, go to File, Examples, Basics, and then click on Blink. So this is the classic LED blinking program, but there's a small twist. On the ESP32C3, the onboard LED is not always on pin 13. For the ESP32C3, it's usually GPIO 8. So we need to change that line in the code. Also, let's add one more thing. We'll add a serial begin function at 1.15200 baud rate. And let's also add a serial.println to print some message to the serial monitor, just to make sure everything's working. Now, if you're using the ESP32-C3, remember there's no external USB to UART chip. Instead, the onboard USB of the ESP32-C3 itself is used for both uploading and the serial monitor. For this to work properly, you must enable USB CDC in the Arduino IDE. Here's how. Go to Tools, USB CDC, on boot, and select Enabled. Alright, now let's quickly upload this program to our board. I forgot the semicolon there. No worries, let's fix it. It might take a little time to upload the code for the first time. Boom, code uploaded, and the LED starts blinking perfectly. Now let's open the serial terminal. Just click here. And make sure you've set the correct baud rate, 115200. Restart the board. I think there's like some small problem. Let's add one more serial println statement inside the loop function. Quickly upload the code again. Boom, guys. Here it is. The serial port is working fine now. And yeah, that's it for this video. In the coming videos, we'll explore more about the ESP32C3. Thanks a lot for watching and see you in the next one.